What lies concealed in the blind spot of the Milky Way? Hidden within the galactic equator of our home galaxy is a mysterious region that obscures our view of what lies beyond. For decades, this enigmatic area, known as the zone of avoidance, remained largely unexplored, shrouded in mystery. However, scientists have now begun to uncover its long-kept secrets, revealing that a massive and previously unknown galactic structure lurks within this cosmic blind spot. Our view of the universe is inherently limited. No matter how much we strain our eyes from Earth, we can only perceive a fraction of the cosmos. Because the universe is isotropic, appearing the same in every direction, a spherical boundary surrounds our planet, defining the extent of our observable universe. This observation horizon marks the farthest regions from which light has reached us since the Big Bang, factoring in the expansion of the universe. This staggering boundary extends 46.3 billion light-years away. Yet, we don't need to look nearly that far to recognize that space imposes its own limitations, keeping some of its deepest mysteries hidden from view. To grasp the significance of this, we must travel back in time to 1878 and examine The Universe of the Stars, a book by Richard Proctor. Within its pages lies a large-scale depiction of cosmic nebulae distribution. Though we now understand these nebulae to be independent galaxies, Proctor, like many astronomers of his era, was unaware of this crucial distinction. The English astronomer was aware, however, that there was a particular region in space that stood out as distinctly different from all the others. When Proctor utilized data gathered by John Herschel to produce an illustration for his book on the universe, he noticed an area in the sky that contained significantly fewer nebulae than the surrounding regions. As a result, he titled the image The Zone of Few Nebulae, laying the foundation for the mystery surrounding one of the most enigmatic areas of the Milky Way. Although the Swedish astronomer Carl Charlier brought attention to this peculiar region again in 1922, it wasn't until 1961 that Harlow Shapley became the first expert to systematically analyze and define this puzzling area, aided by Edwin Hubble's groundbreaking discoveries. By that time, astronomers had already established that the so-called nebulae in the cosmos were actually fully formed galaxies, an insight that had profoundly reshaped our understanding of the universe. Ironically, this realization also challenged Harlow Shapley's own long-held beliefs, as he had previously been a leading proponent of the view that the Milky Way was the only galaxy in existence. But those views were now outdated. By the early 1960s, Shapley's analysis revealed that, on average, there were 54 galaxies per square degree of the sky, a region approximately the size of 5 full moons. Yet, in this particular area, the expected distribution did not hold. Instead of 54 galaxies per square degree, fewer than 5 were observed. Thus, what Proctor had originally labeled as the zone of few nebulae became widely known as the zone of avoidance. Astronomers largely ignored this region, as it seemed to offer little potential for productive research. Why the zone of avoidance poses a challenge for researchers. As mentioned earlier, the zone of avoidance lies along the galactic equator of the Milky Way. But what does that mean in practical terms? To visualize this, we can picture our galaxy as an enormous, disc-shaped structure densely populated with stars. From our vantage point in the solar system, located in the outer regions of the galactic disk, the galactic equator represents the line encircling this disk. From Earth, we can either look toward the galactic north or south, meaning we peer upward or downward out of the disk. By its very nature, our view into the heart of the Milky Way is filled with far more structures and objects than our view outward toward the galactic edge. However, another unavoidable reality is that our home galaxy isn't just made up of twinkling stars, it also contains vast clouds of gas and dust drifting through interstellar space. One significant consequence of this is the presence of the zone of avoidance, a region within the densely packed galactic disk that remains largely hidden from view. Unfortunately, our ability to see into this area is obstructed by the very gas and dust that fill the Milky Way, which absorb and scatter light like a cosmic curtain, concealing whatever lies beyond. To put it into perspective, the zone of avoidance obscures about 10 to 20% of the extragalactic sky, a major blind spot in our cosmic observations. This raises a critical question: how can we truly grasp the bigger picture of the universe when such a significant portion remains unseen? Understanding the universe requires examining it on the grandest scales. For instance, our Big Bang model suggests that even the largest cosmic structures have an upper size limit. If we were to discover galactic superclusters larger than these theoretical limits, it would challenge our fundamental understanding of cosmology. The same applies to unknown phenomena that may be lurking in these hidden regions, waiting to be uncovered. Yet, the zone of avoidance isn't just an obstacle on a cosmic scale, it also affects our understanding of our immediate galactic neighborhood. Without knowing what other galaxies exist in our own cosmic backyard, we lack a complete picture of our local group's evolution and future. But despite these challenges, there's good news. Unlike astronomers of the past, we now have the ability to peer into the zone of avoidance. While visible light is heavily absorbed by dust and gas, infrared light is much harder to block. Today, researchers use infrared telescopes, radio telescopes, and other non-optical methods to study this once-hidden region. These advanced techniques have already revealed some astonishing structures, including one of the largest known galactic formations in the universe. What lies hidden in the zone of avoidance? A major breakthrough came in 2016, when a team of scientists from the University of Western Australia used the Parkes radio telescope to penetrate the Milky Way's veil. By analyzing a specific spectral line emitted by glowing hydrogen, they were able to see through the galactic barrier and confirm that the zone of avoidance is far from empty. In fact, it's teeming with previously unknown galaxies. Their findings were extraordinary. 883 galaxies were identified, a third of which had never been seen before. Among them, they uncovered 3 known galaxy clusters and 2 previously undiscovered ones. Considering that a typical galaxy holds around 100 billion stars, the sheer mass and scale of these hidden structures are mind-boggling. Beyond mapping out unseen galaxies, this discovery also provided key insights into a deeper mystery: what is pulling us? Lurking in this obscured region is the Great Attractor, a mysterious gravitational force pulling hundreds of thousands of galaxies, including our own, toward it. The Milky Way itself is moving in this direction at an astonishing speed of over 2 million kilometers per hour. Based on current estimates, the mass responsible for this immense gravitational pull is equivalent to about 10 quadrillion suns. Given the sheer significance of what lies within the zone of avoidance, it's clear why astronomers are so determined to unveil its secrets. And, indeed, in the years since that groundbreaking discovery, scientists have continued to push the boundaries, revealing more and more of the cosmic puzzle that was once hidden from view. In the fall of 2022, researchers utilized VISTA, an infrared telescope in Chile that surveys the Milky Way's equator,